Imagine the early hours before dawn. The sky is still thick with night. You're outside, maybe halfway between waking and wondering. Then you look up. There it is, a pale golden smudge moving slowly among the stars. It glows with a quiet kind of beauty that feels ancient. Older than you, older than your city, older than anything in your calendar. That smudge is C25 K1 ATLAS. And believe it or not, it isn't just another passing comet. It's one of the most compelling visitors our solar system has seen in decades. Carrying secrets from the distant Oort cloud, wearing an unusual golden glow and revealing part of itself in a dramatic breakup. Today we're going to explore how this icy stranger turned heads, challenged assumptions, and reminded us just how strange and magnificent the cosmos can be. Why should you care about something so remote, so fleeting? Because in that golden trail lies a story of origins, the raw ingredients of our solar system laid bare. Because it survived a scorching close encounter with the sun and emerged altered yet intact. Because everything about it, the color, the chemistry, the split fragments, whispers that this is not a typical comet. It's an anomaly. It's a teacher. And it's here for a brief moment in our cosmic timeline. So let's set the scene. On the morning of May 24th, 2025, robotic telescopes run by the Asteroid Terrestrial Impact Last Alert System, ATLAS in Hawaii, discovered what would become C 2025 K1. At first, it looked like yet another blob on the scanner. But follow-up observations revealed that this body was bound for a daring close passage around the sun, a journey that would take it into extreme heat and pressure, and ultimately into our gaze as something extraordinary. Fast forward to October of that year. The comet dives into around 0.334 AU from the sun, closer than Mercury ever gets. It's a perilous dance. Many comets that venture this near fall apart or fade into nothingness. But C 2025 K1 doesn't give up easily. It emerges from the solar furnace still trailing dust, but changed. The coma, the fuzzy cloud of gas and dust around the nucleus, takes on a golden-brown cast rather than the typical eerie green or blue seen in many comets. Why? Because the usual suspects, carbon-based molecules like C2 and CN, are missing or depleted. The chemistry is odd. The behavior is odd. Scientists lean in. And then, as if the show didn't have enough drama, the comet begins to fragment. What started as a single nucleus now splits into 2 or 3 pieces. Each piece carries a part of the story, of stress, of heat, of cosmic radiation, and opens a window into the structure of these ancient bodies. Because when a comet breaks, it leaks its internal secrets, dust layers, icy pockets, maybe even clues to how these objects formed billions of years ago. That's the hook. That's the moment of wonder. A frozen visitor from the depths of the solar system, glowing gold, splitting apart, inviting us to watch. Imagine yourself with a pair of binoculars or a small telescope. Sky still dark, horizon just hinting at dawn. You spot that golden smudge. You know what most people don't yet. It's a relic from a time before Earth had neighborhoods or languages or albums on streaming. You're part of the story. And here's one more reason to keep watching. This isn't just about spectacle, it's about meaning. By studying C2025 K1, we learn about the earliest chapter of our own planet's formation. We learn how solar heat transforms comets. We learn how objects from the outer solar system behave when they get their first chance at the center stage. And if we understand comets, we understand the distribution of water, organics, and even the seeds of life. So stay tuned, because in the next sections we'll break down exactly how this comet was discovered, the journey it took toward the sun, the chemistry that surprised us, how it compares to another exotic visitor called 3I ATLAS, what it all means for humanity, and yes, how you might even spot it yourself. For now, keep that golden smudge in mind. It's small, it's distant, but in its story we find the big questions. Where did everything come from? And where might we be headed next? The discovery, a blink in the dark that changed everything. How a quiet night in Hawaii introduced the world to a golden wanderer. Discovery stories in astronomy are rarely loud. There's no dramatic thunderclap, no cosmic drum roll. Most breakthroughs begin with a machine doing its job quietly in the background, while the universe casually drops something extraordinary into the frame. That's exactly how C2025 K1 ATLAS entered the story. Picture the Atlas Observatory in Hawaii in late May 2025. The air is cool, the night is calm, and the robotic telescopes are sweeping the sky methodically, frame by frame. Atlas isn't built for glamour, it's built for vigilance. Its full name, Asteroid Terrestrial Impact Last Alert System. Sounds like it belongs in a disaster movie. Its mission, though, is beautifully simple: scan the heavens each night for objects that might wander too close to Earth. On May 24, 2025, somewhere in the quiet hum of its automated routine, Atlas flagged something faint. Not an asteroid, not a flare, not noise, something smudged and fuzzy drifting between the stars, a comet. At the moment of discovery, it didn't even have a name, just a set of coordinates and a whisper of motion. But as soon as human astronomers examined the data, eyebrows went up. A new comet is already interesting. A new comet headed for a very close brush with the sun? That's a plot twist. Within hours, follow-up observations from other observatories confirmed that this object wasn't just another icy pebble wandering the solar system. It had a long, elongated orbit, meaning it came from far beyond the planets, from the shadowy, distant Oort cloud. This is the freezer of the solar system, the cosmic storage unit full of leftovers from its earliest days. Every comet that arrives from that region is like a time capsule from 4.5 billion years ago. Astronomers began calculating its orbit more precisely, and that's when the excitement kicked up a notch. C2025 K1 was on course for a perihelion, its closest approach to the Sun that was closer than Mercury's orbit. That's a high-stakes journey. Most comets don't survive that kind of heat. Those that do come out looking altered, scorched, sometimes dramatically transformed. And then there was the other question. What would it look like when it woke up? Comets are sleepy, frozen lumps out in the cold. But as they swoop inward toward the sun, they stretch, crack, and release plumes of gas and dust. Their true personalities come out only when they warm up. Some become bright, some grow long tails, some remain unremarkable. C2025 K1. That one turned out to be a bit of a show-off. But let's not get ahead of ourselves. Back in those first days of discovery, all astronomers had was a faint streak and a lot of anticipation. anticipation. The object was brightening slowly, its path was narrowing, and then came the timeline. The comet would reach perihelion in October 2025, giving the world several months to prepare for what could be one of the most intriguing sky events in recent years. By early June, the discovery was officially catalogued and named C2025 K1 ATLAS. The C means it's a non-periodic comet, one that won't come back in our lifetime. 2025 K1 tells us when it was discovered, and Atlas is a nod to the robotic watchman that first spotted it. From that point forward, astronomers across the globe pointed their instruments toward it. Amateur skywatchers started sketching. Observatories tracked its subtle changes. This little speck in the sky suddenly had an entire planet watching its arc through space. And then something unexpected happened. As C2025 K1 brightened, it didn't display the usual greenish glow that comets often show due to carbon-based molecules. Instead, it developed a warm golden tint like a torch drifting across the cosmos. That unusual color hinted at unusual chemistry. A different mix of ices, a different history, a different kind of ancient. When it finally dove close to the sun in October, part of the nucleus fractured, a cosmic stress test revealing its inner layers. Fragmentation isn't uncommon for comets, but every breakup is a scientific gold mine. When a comet cracks open, it stops hiding. It shows you what it's made of, layer by layer, like a cosmic fossil split neatly in two. All of this, the discovery, the golden glow, the close solar dive, the fragmentation, made astronomers sit up straighter. Atlas had stumbled upon something rare. Not a catastrophe, not a threat, just a celestial traveler carrying clues from a time before Earth was even Earth. And the best part, none of this started with fanfare. It began with a robotic telescope doing its nightly sweep and catching a faint blur no bigger than a pixel. A blink in the dark, a quiet alert. And suddenly, humanity had a new mystery to unravel. Every great cosmic story begins like that, small, humble, almost invisible. Then with time and curiosity, it unfolds into something awe-striking. C2025 K1 is one of those stories, and its discovery is the first chapter. The next chapters only get wilder. The journey toward the sun, a frozen wanderer enters the fire. How C2025 K1 turned a routine solar flyby into a cosmic drama. The journey of a comet is never a straight line. It's a long, looping pilgrimage, carved by gravity, sculpted by time, and nudged by the quiet forces of the universe. C2025 K1 ATLAS began its voyage long before humans knew how to write, or count, or look up and wonder. It started in the Oort cloud, that distant halo of icy debris surrounding the solar system, like an ancient reef made of frozen relics and cosmic leftovers. Out there, the sun is just a pale lamp, barely more than a star among stars. Thousands, maybe millions of years ago, something disturbed this comet. It could have been a passing star brushing by the solar system. It could have been a tug from the galactic tide. Whatever it was, the quiet was broken. The comet was knocked from its slumber, set on a slow inward spiral toward the light, and that slow fall toward the sun is what we're witnessing now. When C2025 K1 began waking up in early 2025, It was still just a cold block of ice and rock. But as it slipped deeper into the sun's influence, the heat began its work. Comets don't melt, they sublimate. The ice turns straight into gas without becoming liquid in between, creating jets that shoot off the nucleus like tiny geysers. These jets shape the coma, the glowing cloud around the comet, and push the dust outward in long tails that stretch across the night sky. Here's where C-2025 K1 started breaking the rules. Most comets glow green or bluish when they heat up, thanks to carbon-based molecules that fluoresce under sunlight. But this one decided to glow gold, a strange, warm amber tint. It wasn't just a pretty quirk, it was a chemical confession. It meant this comet was low in the carbon molecules that usually paint comets green. It meant something different was cooking beneath its surface. Something older or rarer or processed by eons of cosmic radiation, as the comet plunged deeper into the inner solar system. Astronomers watched closely. They calculated its path again and again, refining each detail as it approached that critical moment. Perihelion, the closest point to the sun. And this wasn't just any perihelion. This comet was hurtling toward a scorching dive of 0.334 AU. That's closer to the sun than Mercury ever dares to go. You have to imagine what that means for a comet. It's like throwing a snowball into a bonfire and expecting it to hold itself together. The temperature skyrockets, the radiation intensifies, the pressure on the nucleus builds until even the toughest comets begin to crack. In October 2025, the comet entered the furnace. For a while, it looked like it was holding strong. It brightened. Its tail extended. Observatories captured images of a golden coma glowing like a lantern on a cosmic cliff edge. But then the pressure peaked, and C-2025 K1 reached its breaking point, literally. The nucleus fractured, not catastrophically but clearly. It split into fragments, each one trailing its own plume of dust. It was like watching a cosmic egg crack, revealing the raw layers beneath the shell. Comet fragmentation is dramatic, but from a scientific perspective, it's pure treasure. A fragmented comet exposes its interior. Ice that hasn't seen sunlight since before Earth formed. Dust older than the moon, structures that formed in the dawn of the solar system. People imagine comets as solid chunks of rock, but they're more like dirty cosmic snowballs held together by hope, gravity, and frozen gases. When C-2025 K1 broke, it was simply showing us its true nature, fragile, layered, ancient. The fragments didn't scatter wildly. They drifted, still bound by the original orbit, still following the same sweeping arc around the sun. Each fragment was like a chapter torn from a book, but still following the same storyline. The breakup didn't end the journey, it simply rewrote it. After the perihelion passage, something remarkable happened. The comet survived. Many comets disintegrate completely after such a close solar encounter, vanishing into faint dust clouds. But C-2025 K1 came out battered, bruised, but undeniably alive. That alone made it special. Its brightness fluctuated, its tail reshaped itself. The color stayed warm and distinctive, and astronomers began stitching together the story. A comet from the outermost reaches of the solar system had just cruised through a solar inferno and lived to tell the tale. This journey wasn't just physics and orbital dynamics. It was a drama. It was a story about endurance. It was the cosmic equivalent of watching a wanderer walk into the fire, crack under the heat, and still walk out glowing. And for us on Earth, watching from the safety of our blue marble, it was a reminder of something humbling. Every object out there, every comet, every asteroid, every drifting speck, carries a story older than our species. But only a few, like C225 K1, choose to tell it in such spectacular style. The journey toward the sun was the trial by fire. The next part of the story is what the comet revealed in that furnace, and why scientists are treating it like a rare cosmic messenger. The Golden Surprise, a comet that broke all the rules. Why C2025 K1's strange golden glow became the biggest plot twist of its entire journey. Every comet has a personality. Some are shy and dim, some flare up unpredictably, some behave so normally that astronomers barely look twice, but then there are the troublemakers, the ones that refuse to follow the usual script. C2025 K1 landed firmly in that last category the moment it started glowing gold. Comets aren't supposed to glow gold, not in the traditional sense. Their chemistry usually pushes them toward greenish or bluish hues as they heat up and release gases like diatomic carbon, C2, and cyanogen, CN, both of which fluoresce under sunlight. That's why so many comets look like mint candies drifting through the void. But when C2025 K1 approached the sun, telescopes captured something odd. Its coma didn't look green, it didn't look blue, it wasn't even the usual white. It took on a warm, rich golden tint like a lantern carried through the dark of space, a color that almost felt alive. You could imagine ancient navigators spotting something like this in the sky and inventing myths on the spot. The moment this golden glow appeared, astronomers perked up. Color in astronomy is a form of confession, the universe admitting what something is made of. If the glow is wrong, the chemistry is wrong. And if the chemistry is wrong, the comet isn't what we expected. Turned out, this comet was carbon poor, very carbon poor. That alone is weird, because most comets are packed with carbon-based molecules. These molecules are the reason comets glow the way they do. Without them, the comet doesn't get the classic emerald halo. Instead, sunlight scatters off dust grains in a different way, creating that golden hue. It's like the cosmic equivalent of someone showing up to a party dressed in full gold while everyone else is wearing the same green suit. You notice. Now, the big question, why is this comet carbon poor? That's where things get interesting. There are two working theories. One, this comet was born in an unusual region of the early solar system, somewhere colder or shielded from certain types of radiation, allowing different ices to dominate its composition. Two, it has been sitting in the Oort cloud for so long, exposed to cosmic rays for millions of years, that parts of its chemistry were altered over time. Imagine sunlight slowly bleaching a piece of fabric. The universe does that to comets too, just at a scale of centuries and millennia. Both theories point to the same conclusion. This comet is a chemical oddball, and oddballs are priceless. They offer clues about the conditions of the early solar system that ordinary comets simply can't. Then came perihelion, the closest approach to the sun. This was the critical test. Would the golden glow intensify? Would the comet survive? Would it break apart completely? What happened was equal parts expected and astonishing. The glow didn't just stay, it deepened. As the heat ramped up, the comet's dust production surged. More dust meant more sunlight scattering, and more scattering meant richer color. The golden coma and tail became clearer, brighter, almost theatrical. It wasn't just scientifically interesting. It was visually poetic, like the comet was wearing a burning cloak as it raced past the sun. But perihelion also brought something dramatic: fragmentation. Under dozens of times the heat we experience on Earth and solar pressures that tug at every molecule, the nucleus cracked. At least one major fragment separated, forming its own mini coma and dust tail. This kind of breakup is stressful for a comet, but ridiculously valuable for science. A fractured comet exposes layers that haven't been touched since the solar system was a swirling disk of gas and fire, layers that contain different ices, different dust, different stories. Scientists studying these fragments can compare what's on the surface with what's inside. And that comparison is like reading a diary written by the early universe. The golden dust didn't fade after the breakup. If anything, the fragments glowed even more distinctly, as if the comet's inner structure was even more reflective or uniquely shaped. You don't often get a comet exposing its guts to the world, but when one does and the guts look like gold dust, that's when astronomers lose sleep, not from worry, but from excitement. This golden signature set C 2025 K1 apart from nearly every major comet of the modern era. It wasn't as large as Hale-Bopp. It wasn't as bright as Neowise. But it was stranger, chemically stranger, visually stranger, behaviorally stranger. And strange is good in science. Strange is where the secrets hide. The universe has a habit of surprising us with oddities that rewrite small parts of the cosmic rulebook. C 2025 K1's golden glow is one of those surprises. A reminder that not all comets are built the same, not all wanderers follow the script, and sometimes the smallest things, dust grains, faint colors, subtle fractures, open the biggest windows into the past. The golden surprise wasn't just an aesthetic moment, it was a scientific revelation. But the next section goes even deeper. Why this comet matters to humanity and what it's teaching us about our origins. Why this comet matters, a messenger from the edge of time. What C 2025 K1 reveals about our origins, our future, and our fragile place in the cosmos. There's a reason scientists get emotional. Yes, emotional about comets like C 2025 K1. On the surface, it's just a dusty ice ball having a very bad day near the sun, but underneath the drama and the golden glow, this comet is something far more meaningful. A messenger carrying secrets from a time before Earth had oceans, before the moon existed, before life took its first breath in some ancient tide pool. To understand why this comet matters, you have to imagine the solar system not as it is now. Neat, stable, polite, but the solar system as it was. Chaotic, violent, raw, billions of rocks colliding, ice spiraling through space, dust clouds collapsing under their own gravity. It was a mad cosmic workshop where the sun, planets, moons, and comets were all forged in fire and ice. And then once that workshop settled, the leftover pieces, the ones that didn't collide, didn't melt, didn't grow, were thrown outward into deep freeze. Into the Oort cloud, far beyond the orbit of Pluto, past all the noise, past all the planets. Out there, time barely moves. Temperature drops so low that even nitrogen freezes solid. Conditions don't change for millions of years. These are the conditions that preserved C2025 K1. So when it falls inward and we get to study it, we're not just looking at a visitor. We're looking at a memory, a preserved relic, a cosmic time capsule, something that has been untouched longer than any fossil, any rock, any geological layer on Earth. That alone makes this comet valuable, but the story gets richer. C2025 K1 isn't a normal comet. It's carbon-poor, golden-hued, chemically weird. These quirks mean it doesn't fit neatly into the categories we already use. It's like finding a fossil that doesn't match any known species. You don't throw it away, you rewrite textbooks. The comet's odd chemistry suggests it formed under very rare conditions. Maybe in a pocket of the early solar system that was colder than normal. Maybe shielded from certain light wavelengths. Maybe in a region filled with minerals that are now extinct. Each possibility carries implications. If it formed in a unique region, then that region tells us something about the building blocks that shaped Earth. If cosmic rays altered it over millions of years, then we're learning about the slow, invisible weathering that happens at the edge of the solar system. If its dust contains rare minerals, that could reveal how the first planets glued themselves together. This isn't just trivia. Understanding early solar materials helps us understand how planets form around other stars. It helps us decode the chemistry required for life. It helps us understand what makes Earth rare, or not rare, in the cosmic lottery. Then there's the fragmentation. When the comet cracked at perihelion, it gave us a gift, a cross-section of its interior. Comets rarely volunteer their insides to science. Most stay intact until they break apart completely and fade into dust. But this one cracked just enough to spill secrets while still surviving the trip. By studying the fragments, scientists can compare surface material, processed by sun and radiation, with inner material, pristine and ancient. That contrast is like seeing a planet's crust and mantle at the same time, something you can't normally do without digging impossible holes. And beyond the science, there's something more poetic here. Comets remind us that the universe is full of wanderers that travel for millennia, only to burn brilliantly for a few months in our skies. They remind us that everything, planets, stars, even our sun, has a history deeper than our species can imagine. They remind us that our world was built grain by grain, molecule by molecule, by ancient chemistry still drifting through the cosmos. C2025 K1 is also important for studying potential impact risks. Not because it's a threat, its orbit is safely distant, but because each new long-period comet teaches us how these objects behave near the sun, how they fragment, how they brighten, how they evolve. This knowledge helps refine early warning systems, search algorithms, and planetary defense strategies. One day, an object like this might not pass harmlessly. The more we understand now, the better prepared we are later. But the biggest reason this comet matters? It brings perspective. Earth spins through an ancient, dynamic system. We're not at its center. We're just passengers on a rock that's lucky enough to be warm, wet, and alive. When a comet falls sunward, survives the heat, and paints the sky gold, it reminds us that we're part of a much larger story. One written in ice, dust, gravity, and time. C 2025 K1 is a messenger from the deep freeze, a survivor of fire, a storyteller of origins. And even after it fades from our telescopes, what it taught us will echo through labs, textbooks, and imaginations for years. The next section takes this even further. How this comet stacks up against other iconic ATLAS discoveries, and why scientists consider it one of the most intriguing newcomers in years. How it compares to 3I ATLAS. Two wanderers, two very different stories. Why C 2025 K1 isn't just another ATLAS discovery, and how it stacks up against the legendary interstellar visitor 3I ATLAS. Every time ATLAS spots something unusual in the sky, astronomers perk up. But there's a special category of objects that earn a permanent place in the Cosmic Hall of Fame. One of those was 3I ATLAS, an interstellar comet. Yes, interstellar, meaning it literally drifted into our solar system from another star. So naturally, the moment C 2025 K1 was named, comparisons started swirling. Both have the ATLAS tag. Both surprised astronomers, both made headlines. But beneath the surface, these two objects couldn't be more different. One is a native. The other was a tourist. One carries the DNA of our own solar system. The other brought foreign chemistry right through our cosmic living room. And that difference changes everything. Start with the origins. C 2025 K1 is homegrown. It was born in the Oort cloud, the icy sphere that surrounds the solar system like a distant shell. This region is filled with debris left over from the formation of the planets. These comets are the long-lost siblings of Earth's building blocks. When one drops inward, it brings back memories of the dawn of our planetary system. Meanwhile, 3I ATLAS was an outsider. It didn't belong to our sun. It drifted between stars for who knows how long, millions, maybe billions of years, before gravity nudged it into our system. It was the second confirmed interstellar visitor after Oumuamua. Studying it was like examining a meteor from another galaxy. Total alien chemistry, total outsider physics. You don't get that every day. Now compare their physical states. C 2025 K1 is a dynamic, expressive comet. It brightened dramatically as it approached the sun. It released dust. It grew a golden coma. It sprouted a long, elegant tail. It even fractured at perihelion, revealing fresh material from deep inside its nucleus. This is the classic, but still scientifically thrilling, behavior of a sun-warmed long-period comet. 3I ATLAS. Completely different. It was fragile to the point of absurdity. It disintegrated early before it could do much. Instead of growing a robust coma, it broke into pieces and faded fast. It behaved like a snowball thrown too close to a bonfire. It never stood a chance. Scientists barely had time to study it before it vanished into irrelevance. But those brief moments of observation were priceless because they offered the first real data on how interstellar comets behave. Then comes chemistry. C 2025 K1 shocked everyone with its carbon-poor, golden-hued dust. That tells us something important. It didn't form like typical comets. Its nursery had a chemical signature that's different from the usual green coma carbon-loving crowd. This helps scientists map out the diversity of building materials that shaped planets in our system. 3I ATLAS, on the other hand, carried alien chemistry. Some of its components didn't match norms seen in Oort cloud comets. Its dust grain structures appeared strange. It broke apart before detailed analysis, but even the limited data suggested it was shaped by processes that don't happen around our sun. That's huge. It meant we had proof that planet-forming chemistry works differently in other star systems. Now consider their value to humanity. C-2025 K1 teaches us about our own origins. It's a chapter in our story. Its cracking, glowing, dust-rich journey helps scientists refine models of solar system formation, comet survival, and long-period dynamics. Studying its fragments reveals how early Earth might have been seeded with water or organic molecules. Its behavior near the Sun improves comet prediction models for future planetary defense scenarios. 3i ATLAS tells us something different, something broader. It teaches us about the universe's diversity. Studying an interstellar comet gives us a sneak peek into how distant solar systems operate. It's like finding a stone from a continent you've never seen. It expands our imagination and informs theories of how common or rare Earth-like environments might be. Both are important, both matter, but they matter in different ways. Then there's the emotional factor. 3i ATLAS was mysterious because it came from somewhere unknown. Its orbit told a story of cosmic wandering across unimaginable distances. It felt like catching a message in a bottle from another star, a brief encounter with something truly foreign. You can't help but feel awe when a visitor from the wider galaxy strolls into your front yard. C-2025 K1 carries a different emotion. It feels familiar yet strange, alien yet family. A relic of our own past that arrived wearing a golden cloak and breaking apart like a storyteller revealing its heart. Watching it was like watching the solar system whisper its own childhood secrets. The final difference is longevity. C-2025 K1 will likely remain observable longer. Its fragments and dust trail will let astronomers track it for months, maybe years. 3i ATLAS. It was gone almost as quickly as it appeared, an interstellar spark that fizzled before it could tell its full story. In the end, comparing these two objects is like comparing two travelers. One is a long-lost relative returning home, carrying memories of your shared family history. The other is a stranger passing by from a distant land, carrying stories you may never fully understand. Both enrich the human story, both deepen our understanding of the universe, and both remind us that the sky is full of wanderers, some born here, some from unimaginable distances, each with their own lessons to leave behind. The next section will dive into the timeline of the comet itself, from its discovery to its golden transformation, laying out the journey step by step. Why C-2025 K1 ATLAS matters to humanity. How a wanderer from the edge of the solar system expands our future. When a comet like C-2025 K1 drifts into our cosmic neighborhood, it's easy to treat it as a visual spectacle, a pretty arc of dust across the night sky destined for Instagram posts and telescope live streams. But that's the shallow end of the story. The deeper tale, the one that actually nudges humanity forward, has far more to do with what these icy wanderers carry, what they represent, and what they help us understand about our own origin and fate. At its core, a comet is a time capsule, not the neat little metal tube someone buries in a schoolyard, but a primordial storage locker from a time before Earth even existed. C-2025 K1 didn't form yesterday, last century, or even last geological era. It comes from the early solar system roughly 4.6 billion years ago, when everything was chaos and collisions and wild cosmic chemistry. That makes it a messenger, not just delivering dust and ice as it swoops by, but carrying untouched material that predates every mountain, ocean, continent, and organism that has ever lived on Earth. For scientists, this is priceless. Comets like C-2025 K1 tell us what the solar system was made of at birth. They carry organic compounds, frozen gases, and minerals that have never been altered by planetary processes. Every time astronomers analyze a comet's composition, they're essentially cracking open the universe's oldest recipe book. And when one comes close enough to observe in high detail, like this one will, scientists gain a fresh batch of data to refine theories about how planets form, how water arrived on Earth, and how life might have found its chemical foundations. Beyond scientific curiosity, comets play a silent role in humanity's safety planning. We live in a cosmic shooting gallery. Asteroids, meteoroids, and comets all drift along paths that occasionally cross our own. Learning how large comets behave as they approach the inner solar system sharpens our understanding of orbital mechanics, fragmentation behavior, and potential deviations caused by jets of sublimating ice. The more we observe objects like C-2025 K1, the stronger our predictive models become. That matters because one day the object coming toward us might not be just a harmless visitor. And then there's the cultural side. Humanity has a long history of misreading comets as omens, disaster signs, cosmic warnings. But centuries later, we've transformed that fear into curiosity. Today, a comet sighting does something surprisingly valuable. It reminds billions of people that the sky is not just a backdrop. Space is alive, dynamic, moving, changing. It shakes us out of our invisible bubble and makes us look up, literally. Events like C-2025 K1's arrival tend to spark a global wave of excitement. Scientists observe, students research, amateurs drag out old telescopes from their garages, space agencies publish images, kids ask questions, and when a whole planet looks up at the same object, even for different reasons, it's a rare moment of shared wonder in a world usually fractured by headlines and noise. It might sound poetic, but there's something genuinely unifying about a comet passing overhead. C-2025 K1 also highlights the growing power of modern sky surveys. It was discovered early, tracked quickly, and its future path calculated with precision, all thanks to automated systems that allow us to watch the sky with more accuracy than at any point in history. Its journey is proof that humanity is slowly but surely building a comprehensive early warning system for the entire solar system. That's not just fascinating, it's essential. And finally, this comet is important because it reminds us how small and yet how capable we are. Something born on the frozen edge of the Oort cloud beyond the reach of sunlight has traveled for millions of years to glide past a little blue planet whose inhabitants can now detect it, track it, study it, live stream it, photograph it, and explain it. That's a degree of cosmic literacy our ancestors never dreamed of. In the grand scheme of things, C 2025 K1 isn't just a comet, it's a spark, a moment that pushes science, inspires curiosity, advances technology, and reminds humanity that our story is entangled with the universe in ways we're only beginning to understand. C 2025 K1 ATLAS versus 3I ATLAS, the tale of two cosmic wanderers. When you put C 2025 K1 ATLAS and 3I ATLAS side by side, it feels like comparing two travelers from wildly different storylines, one a faithful citizen of our solar system, the other a fleeting visitor from the deep interstellar dark. Both discovered by the Atlas survey, both vital in their own way, yet their natures couldn't be more different. Let's start with C 2025 K1, our homegrown wanderer. This comet comes from the Oort cloud, that enormous spherical shell of icy debris surrounding our solar system like a ghostly halo. Picture it as the attic of the sun's house, dark, full of old relics, and untouched for billions of years. C 2025 K1 was born here, grew old here, and after an eternity of drifting in frozen slumps, something nudged it inward. Maybe a passing star, maybe a gravitational ripple. Whatever the trigger, it sent this ancient object rolling down the long staircase toward the inner solar system. And now, for the first time in its entire existence, it's paying us a visit. Now jump to 3I ATLAS, the second confirmed interstellar object ever detected. After the famously cigar-shaped Oumuamua. This one wasn't born in our attic. It wasn't born anywhere near us. It came from another star system entirely, carrying material shaped by the chemistry of a different cosmic neighborhood. When 3I streaked through our solar system, it didn't slow down, didn't linger, didn't loop around the sun. It simply passed through, tipping its hat to gravity and moving on. It was like a tourist stepping off a long-distance train, taking one glance at the platform, then hopping right back on. C 2025 K1 is a storyteller. It carries memories from our own solar system's childhood. The dust on its surface, the gases trapped in its ice. These are clues about how we came to be. It's not exotic in the sense of coming from another star, but it's invaluable because it tells us about the building blocks of Earth itself. 3I ATLAS, on the other hand, was a mystery gift delivered by the universe. An interstellar postcard, something forged in an entirely different star system, shaped by forces and materials we may never otherwise touch. Even brief observations of its behavior and composition expanded our understanding of what other planetary systems might produce. If C 2025 K1 is a time capsule, 3I ATLAS is a sampler from the cosmic marketplace. Evidence that planetary formation is happening everywhere in the galaxy, not just here. Where C 2025 K1 gives us a chance to observe a pristine comet up close with enough time to prepare telescopes and instruments, 3I ATLAS was a surprise flash. Detected late, studied hurriedly, and gone before many telescopes could lock onto it. One gave us a marathon, the other gave us a sprint. There's also a difference in scientific appetite. With C2025 K1, researchers can map its orbit, predict its approach, study how sunlight heats its surface, and even compare it to other Oort cloud comets. Its path is curved, bound by the sun. It comes in, it arcs around, and eventually, whether now or millennia from now, it will swing back out into that dark envelope it came from. 3I ATLAS broke every rule. It wasn't bound to the sun. It wasn't part of our gravitational club. Its orbit was hyperbolic. An open road, not a closed loop. It came from a place we can't trace and will leave toward a place we'll never follow. Studying it gave scientists new models for interstellar debris and helped refine searches for future visitors. In a strange way, CU 2025 K1 represents consistency, what our solar system has produced and stored for billions of years. 3I ATLAS represents possibility, the hint that countless worlds elsewhere are shaping their own icy wanderers, some of which occasionally drift our way. And here's the beautiful part, both matter. One teaches us about home. The other teaches us we're not the only home. With these two, we see both sides of cosmic storytelling, the familiar and the wildly foreign. Together, they remind us that our solar system is not isolated. It's part of a vast, interconnected galactic neighborhood where objects wander between stars like cosmic hitchhikers. The future of comet research. What C 2025 K1 means for the next generation of space exploration. Every once in a while, a comet arrives not just to dazzle the night sky, but to quietly shift the trajectory of future science. C 2025 K1 ATLAS is shaping up to be that kind of visitor. Not because it's unusually bright or dangerously close or carrying some Hollywood-level twist, but because it lands at a moment when our tools, our ambitions, and our questions are sharper than ever. Its arrival is a spark at the beginning of a new chapter in how humanity studies, understands, and prepares for celestial wanderers. Think of comet research like archaeology with better lighting and worse weather. Comets are frozen artifacts from the birth of the solar system. Every time we get a good look at one, we refine our cosmic history books. But this one shows up at a perfect storm of readiness. Surveys like ATLAS, Pan-STARRS, ZTF, and ESA's upcoming Comet Interceptor mission mean we can track, predict, and analyze a comet's behavior with precision we never had 20 or even 10 years ago. C 2025 K1 is arriving right at the moment when our scientific infrastructure is tuned to pick apart every detail. This comet's trajectory will let researchers test new modeling techniques for dust evolution, gas jets, and heat-driven transformations on a nucleus that hasn't been warmed by the sun in millions of years. These aren't just academic questions. Understanding how comets behave as they approach the sun helps scientists develop better strategies for monitoring potential hazards, planning spacecraft encounters, and estimating the likelihood of fragmentation events. Those unpredictable bursts that turn one solid object into a shotgun blast of smaller ones. The more precise our predictions become, the safer our planet is in the long run. The other point is timing. Missions like ESA's Comet Interceptor are designed to sit and wait for a dynamically new comet, exactly the category C 2025 K1 belongs to. While Interceptor won't launch until 2029, comets like this serve as rehearsal data. They help mission planners simulate what an untouched comet might do as it nears the inner solar system. Every wiggle in its orbit, every puff of dust, every unexpected brightness change is a new data point feeding into the software that will guide future spacecraft. There's also the tantalizing idea of sample return missions. Japan's JAXA and NASA are both floating concepts for missions that could land on or near a comet and bring back pieces to Earth. If those plans ever gain momentum, comets like C 2025 K1 offer a perfect case study in target selection. How stable the orbit is, how volatile the surface becomes, and how predictable the activity patterns are. These details determine everything: lander design, approach trajectory, shielding, and even sample collection tools. But the future isn't just about robots. We're entering an era where amateur scientists contribute massively to comet science. Backyard telescopes today can produce images that would have been considered professional grade 20 years ago. A comet like C 2025 K1, bright enough and close enough for widespread observation, will likely become one of the most documented comets ever. Every image helps refine the comet's rotation rate, gas emissions, and fragmentation patterns. Citizen science turns the whole planet into a makeshift observatory. More importantly, comets like this fuel the imagination. It's no accident that major scientific leaps often follow major public fascination. When the whole world gets excited about a cosmic event, agencies get more funding, researchers get more attention, and kids start dreaming about astrophysics instead of accounting. Inspiration is a quiet accelerant, and objects like C 2025 K1 supply it in bulk. What happens after 2025? The data we gather from this comet will feed research for decades. It may end up redefining parts of our models for Oort cloud dynamics. It may provide new clues about how organic molecules traveled during the early solar system. It may refine the numbers behind impact risk planning. In a way, C 2025 K1 is not just a comet. It's a classroom, a test subject, a catalyst. The future of comet research is headed toward quicker response missions, automated surveys, machine learning pattern recognition, and probably far more interstellar visitors than we've seen so far. C 2025 K1 arrives at the beginning of this new technological wave, like a guest who walks into a party just when the music changes. And as comets continue to sweep through our skies, each one will nudge us toward better tools, deeper theories, and a clearer understanding of our cosmic story. So 2025 K1 is simply the next stepping stone in that long, winding path. Public reaction and global sky watching. How C 2025 K1 is turning the world into one giant observatory. Every so often, a celestial visitor manages to slip past the noise of social media, politics, and everyday chaos to grab the planet by the collar and make everyone look up. C 2025 K1 ATLAS is shaping up to be one of those rare guests, the kind that turns millions of people into temporary astronomers, even if they've never looked through a telescope before in their life. And honestly, watching humanity react to a comet is almost as fascinating as the comet itself. There's a certain poetry in the way people respond to a cosmic event. It begins quietly, like a rumor traveling through stargazer circles. Hey, there's a new comet coming in 2025. A few amateur astronomers start posting early images. Small fuzzy dots with captions like, "Just wait, it'll get brighter." Then the news trickles upward from niche blogs to science pages and then into mainstream headlines. Suddenly everyone's talking about it. People who can't name a single planet except Mars start asking where to look. Couples plan night drives. Kids drag parents to rooftops. Every comet becomes a small global migration, from beds to balconies, from living rooms to open skies. C 2025 K1 hits this sweet spot of excitement. Bright enough to be noticed, rare enough to feel special, predictable enough that live streams, sky maps, and viewing events are already popping up like cosmic popcorn. It's not just astronomy communities buzzing. Photographers, educators, journalists, TikTok creators, and even astrologers, wrong crowd but enthusiastic nonetheless, are warming up for the show. And each group brings a different kind of electricity. For professional astronomers, the comet is a laboratory. For casual stargazers, it's an event. But for the public at large, it becomes something softer and more human. A shared moment of awe. People rarely gather to watch something that isn't man-made. Fireworks, festivals, concerts, sure. But a comet? That's nature's own theater, running a show written billions of years ago. The global reaction also reveals something endearing about us. Even in the middle of our busy digital lives, the universe can still interrupt us. A piece of ice and dust the size of a mountain wanders into view, and suddenly entire nations are searching best time to see comet tonight like kids chasing a rare bird. It's a reminder that wonder is still a basic human instinct, buried but not lost. And then there's the social side of it. Comet 2025 isn't just a sky event, it's becoming a cultural event. Expect hashtags, expect time lapses that go viral, expect the moment when someone with a drone tries to film the comet up close. They won't, but points for enthusiasm. Expect global space agencies to share images that get retweeted by millions. Expect a flood of smartphone photos that capture nothing but blurry smudges, yet are cherished as if they were taken by Hubble itself. It's also worth mentioning how comets tend to create temporary unity. Every major astronomical event creates a pulse, something the world collectively feels. When Hale-Bopp lit the sky in the 90s, businesses sold binoculars like hot chai in winter. When Neowise showed up in 2020, people broke lockdown boredom by staring at the sky together. C 2025 K1 may create the same kind of ripple, a moment where the planet pauses, looks up, and remembers it lives in a much bigger neighborhood than it usually admits. What's fascinating is how these reactions build momentum. The closer the comet gets, the more photos appear. The more photos appear, the more people want to see it. Soon, telescopes that sat unused for years get dusted off. Parks fill with quiet silhouettes pointing upward. Astronomy clubs plan meetups. YouTube channels start countdowns. Live streams hit millions of views. It's like the world becomes a single audience before a silent performer moving across the night. And even after the comet fades back into darkness, the impression stays. Kids who see their first comet often grow up curious about space. Adults who never cared about astronomy suddenly buy star tracking apps. Families who rarely do outdoor activities find themselves camped out under a sky they hadn't properly looked at in years. This is the comet's afterglow, not in the sky, but in people. So as C2025 K1 approaches, expect a rising tide of fascination. Expect crowds gathering on hilltops. Expect live streams with dramatic music. Expect headlines that swing between scientific insight and wild speculation. Expect wonder, confusion, memes, jokes, poetry, awe, all mixed together the way only humans can do.